We're going to do notes over trig ratios. So I'm going to do them on this little video, and then you're going to write them down as I'm talking. Sorry that I sound so congested, but it is what it is. So this is going to be, and hopefully you don't hear the pen clicking too much, 2.10 trig ratios. So this is an intro to trig, and trig is a shorter way of saying trigonometry. So last week we learned different ways to solve for right triangles. We did Pythagorean theorem, we did geometric mean. And so trig ratios is just, or trigonometry really, is just another way that we can find missing parts of right triangles. Today we're just going to learn how to set up the ratios, and then later we will learn actually how do you solve things with this stuff. So this is only for right triangles, just like everything else we've done. So we're going to start with drawing a triangle here. And if you need more time, just ask the sub to pause the video so you can catch up or anything like that. So we have ABC, and the important thing about trig ratios is that you're able to label the sides appropriately. So we have 3 different sides. We have the hypotenuse, the adjacent, and the opposite. If you don't label the sides right on your triangle, then all of your answers will be wrong. So something very important is also a reference angle. And our reference angle is going to be C. And so I drew a little theta. It's a Greek letter there. And that's just representing our reference angle. So I'm going to draw a little line there. Reference angle. And this is going to help us label our sides. So, I forgot the right angle. The hypotenuse will never change. We know what the hypotenuse is. It is this side. It is the one opposite from the right angle. The other two are easy to mix up, and that's the opposite and the adjacent. The opposite will always be opposite from your reference angle. This is my opposite, or my reference angle, so my opposite will be over here. This will be my opposite side, opposite from the reference angle. Now that can change, because let's say I move the reference angle. Let's say I don't want the reference angle here, but I want it here. If I put the reference angle at A, that is now going to make BC my opposite side. So the reference angle is super important when identifying your opposite side. So right now our reference angle is here. So this is opposite. And then if that's opposite, that means that our bottom one has to be our adjacent side. And I should have moved reference angle over a little bit, because now I feel like I don't have room to write adjacent. That's adjacent. Okay. Those are our sides. So now let's try to label them real quick over here on an example to the right. So we're going to draw another triangle. And this is going to be P, Q, R. And I'm going to put theta right here. So I actually want you to try to label them. So try to label them opposite, adjacent, and hypotenuse. You don't have to write the whole words. You could just put O, A, and H. So we're going to pause the video now and try to let you label them to see if you can label them correctly. Okay, let's check our answers. Hopefully you labeled PR as the hypotenuse because it's opposite from the right angle. And then opposite from our reference angle. So here's our reference angle theta, or it could also be angle P. You could call angle P our reference angle as well, because theta is at P. Remember, our opposite is opposite from that. So this is the O, which means this is the A. If you get a little confused with the O and the A, also, the A will always touch your reference angle. See how that side touches angle P? It will always touch your reference angle. The opposite side will never touch your reference angle. It's opposite from it, just like it is in the name. Okay, great. So now let me introduce the ratios to you. So we have 3 ratios, and they are sine, cosine, and tangent. And you may have learned about these already a little bit last year. Sine, cosine, tangent. So go ahead and write those down. Now these have abbreviations. So when you find these buttons on your calculator, or you might have seen one of the buttons on your calculator says trig. So if you hit trig, all of these abbreviations will come up. The abbreviation for sine is SIN. Cosine is COS. And tangent is TAN. Also, if you look at like your phone calculator, it'll have these abbreviations. Now, when you're reading it, even though it's the abbreviation, you don't want to say sin, cos, and tan, because it will sound like you don't know what you're talking about. We want to use the like whole word sine, cosine, and tangent. So let's get into the ratios. The sine ratio is opposite over hypotenuse. The cosine ratio is adjacent over hypotenuse. So a ratio is a fraction, remember that. Tangent is opposite over adjacent. So these are the ratios. These are what you're going to need to remember and know. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So now let's get into how do these work? What do we do with them? Again, today we're just learning how to set up ratios. We're not learning how to solve anything yet. So let's draw a triangle. I'm going to work this one with you. Sorry, I see how much paper I have over there. Okay, here's our right triangle. We're going to put some numbers on it. All right, and we are going to find what sine of A is equal to, what cosine of A is equal to, and what tangent of A is equal to. So, if you're looking at the triangle, hopefully you notice something's missing. I didn't give you the reference angle. I didn't put a theta anywhere. But the problem tells you what your reference angle is. Since we want to find sine of A, cosine of A, tangent of A, that means that A is our reference angle. Okay, A is our reference angle. Now we're going to label the sides according to A. Our hypotenuse is the one opposite from the right angle, our longest side, so this is our hypotenuse. Remember, the adjacent side touches your reference angle. So our adjacent side here will be the 12. And then your opposite is opposite from your reference angle. That side does not touch A. So now that we've labeled it, again, remember, it's super important that you label it right, because if you don't, like, all your answers are going to be wrong. Let's go back and look at the ratios. Let's start with sine. The sine ratio is opposite over hypotenuse. So opposite on top, hypotenuse on the bottom. So we're going to go over here to our numbers, and we're going to find the opposite, which is 5, and the hypotenuse, which is 13. So our sine of A will be 5 over 13. Again, because this is our ratio, 5 was the opposite, 13 is the hypotenuse. That's our fraction. For the cosine, we do adjacent over hypotenuse. If you look at the ratio, adjacent on top, hypotenuse on the bottom. So we'll go back to our triangle. Adjacent on top, 12. Hypotenuse on the bottom, 13. The tangent, and then if they simplify, you want to simplify them, but these don't simplify, so they are fine as is. And then tangent, we have opposite over adjacent. So O over A. So we'll look at our numbers. O is 5. A is 12. And again, that is simplified. And so those are our answers. Those are the ratios that we have. Okay. I'm going to draw another triangle, and I'm going to let you try this one. So once I get it all drawn and all that, we'll pause the video and let you try to solve it. All right, a right triangle. We're going to have W, X, Y. And then numbers, we're going to have 9, 12, and 15. And then I want you to find sine of W, cosine of W, and tangent of W. Remember, your reference angle is in the question, so your reference angle will be W. So now we're going to pause it, try to label them, find the fractions. If they simplify, simplify them. All right, hopefully you had enough time to get those answers. So let's label these sides. Our reference angle is W. 15 is our hypotenuse. If you notice, this triangle is facing, the same way as our last triangle. And like the reference angle is in the same spot, so our sides are going to be labeled the same. Opposite from W is the 9 and adjacent is the 12. So let's start. Sine is opposite over hypotenuse, so O over H, 9 over 15. Cosine is adjacent over hypotenuse, so A over H. A is 12 and H is 15. Also, I forgot to simplify, so let's go back and simplify. On the first one, we can divide them both by 3, so we get 3/5. Second one, we can also divide them both by 3, so we get 4/5. Now for tangent, it's O over A. Right here, opposite over adjacent. So opposite is 9 and adjacent is 12. And that simplifies to 3 over 4. All right, check out your answers. See if you got them all right. Good job to those of you who got them all correct. Let's do one more for you to try. So we'll draw one more triangle. Let's see, we're going to draw this a little bit different. Okay, here we go. Let's turn it around on you. See if you can still label them right. So this is going to be B, U, sorry, my screen turned on me again. U, C. And then we're going to have 7, 24, 25. And I want you to find sine of B, cosine of B, tangent of B. Okay, so B is your reference angle. We're going to pause the video, let you see if you can find those, and then we'll check our answers. Check with your neighbor, talk with your neighbor if you need help, and get them. All right, hopefully you had time to check your answers. Let's see. Our reference angle is B. Our hypotenuse is opposite from the right angle, so this is our hypotenuse. Opposite from B is a 24, and then 7 was our adjacent. You can see that the adjacent touches your reference angle as it should. The opposite does not touch your reference angle. So sine, you look at the little ratio, sine is opposite over hypotenuse, so O over H. So that was, still the highlighter, 24 over 25, which will not simplify. Cosine is adjacent over hypotenuse, so that is 7 over 25. That also will not simplify. And our last one, tangent, opposite over adjacent, that is 24 over 7. Notice how that one's improper. Like, it wasn't on any of the other ones, but it is on this one. That is okay. Tangent is the only one that can be improper. Cosine and sine can never be improper. So if you get an improper fraction on those, on the first two, sine and cosine, something went wrong. Only tangent can be improper. And the reason is, look at the ratios. The sine and the cosine both have the hypotenuse in the denominator. And remember that the hypotenuse is the longest side, which means the bigger number will always be on the bottom. So it can't be improper. But the tangent doesn't have the hypotenuse in the denominator, so that would